let's say you wanted to use the method where you rewrite it as a complex fraction. And what you should look at is in this first set of factors, our x squared has no negative power, so it's going to stay in the numerator of a fraction. However, the x squared plus 9 does have a negative power, so it gets moved to the denominator. We change the sign of its power. In the second one, any radicals convert to rational power, so I'm going to convert this square root to a power of 1/2. So minus x squared plus 9 to the 1/2. It stays in the numerator. There's no negative power associated with it. And then the x squared stays in the numerator as well. So once again, I write the over 1 to illustrate that it's staying in the numerators. If you're setting this up, solving it as a complex fraction, you've written it in this complex fraction form. You can now use either of the methods for working with complex fractions. Since the denominator is already written as a single fraction, I'm just going to use the first method. I'm going to combine my numerator into one single fraction. The LCD has to have a factor of x squared plus 9 to the 1/2 and a 1. So here's my LCD. So I'm going to take the first fraction's numerator times any LCD factor that's missing from its denominator. It's not missing anything, so we just leave it as x squared. Minus the next fraction's numerator, x squared plus 9 to the 1/2, times any LCD factor missing from its denominator. Well, it's missing the whole LCD, which happens to be the same thing, so what do we do with their powers? We add them, and so 1/2 plus 1/2 is equal to 1. And so here, really what we're doing to simplify this, we distribute our negative. We get x squared minus x squared minus 9. The x squareds cancel, so I'm left with just a negative 9 over x squared plus 9 to the 1/2. And now instead of dividing by x squared over 1, we're going to multiply by the reciprocal, 1 over x squared. And so multiplying across, we get negative 9 over x squared times x squared plus 9 to the 1/2. No factors were removed or canceled from the denominator, so we don't have to identify any other domain restrictions. They're all apparent in the simplified form. So the alternative to this is to solve this by factoring. So if we factor this, we would write everything in that factored form. So I'm just going to convert this x squared plus 9 into a rational power. And then we are going to remove any common factors. So when we look at this, we have two groups of factors separated by a minus. The common base is x squared plus 9. We're going to take out the smaller of the two powers, which is a minus 1/2. And whatever's left is going to have the same form as our original, which is one group minus another group. And so if we take out a power of minus 1/2, subtracting a negative is equivalent to adding the opposite. So this whole factor gets canceled out, leaving just an x squared in this first group. In the second group, we subtract out a minus 1/2, which is adding the opposite, leaves us with an x squared plus 9 to the 2/2, or 1, the first power. Go ahead and continue, write this all over x squared. You can go ahead and simplify this. So we're going to move our negative power factor into the denominator. So this becomes x squared plus 9. Change the sign of its power to a positive 1/2. And then we're going to simplify up here, distributing our negative. So we get x squared minus x squared minus 9. Those cancel, leaving our minus 9. And then we see that our denominator just carries on. And you get the same thing. It doesn't matter which way you solve it. It all depends on whatever you're comfortable working with.